Hello. Alright, so let's start Java 8 part. Java 8 is nothing but it's a advanced concepts of Java, which is released in 2016. So from Java 8 onwards, there are major changes. What are those changes? We will see. Java 8 is a functional programming language. Okay, so Java 8 is a functional programming language, means working with functions as parameters in simple terms. Or variables. This is what the meaning of functional programming language. We can work with functions as just like we work with parameters or variables. And this feature is supported from Java 8 onwards. And other major changes, Java Lambda expressions. Major changes in Java 8. Major changes from Java 8 onwards. Java 8 onwards. Major changes from Java 8 onwards. So first major change is usage of lambda expressions. Usage of lambda expressions and usage of streams, or you can say introduction of streams. Introduction of streams, lambda expressions, streams are the major changes in Java 8 version. And functional interfaces. And functional interfaces or method references, you can say. Functional interfaces or method references. Java 8. One second. So usage of lambda expressions, introduction of streams, functional interfaces, and method references are the major changes in Java 8 version. Okay, let's see what is a lambda expression. It is an expression that implements functional interface. The usage of lambdas provides lot of saving of lot of code, means boilerplate code will be avoided, means repetition of code will be reduced, lines of number of lines the program stretches will be reduced, lot of boilerplate code will be reduced. Okay, and it provides a clear and concise way of writing applications. It supports code reusability. This is the advantage of lambda expressions. So what is a lambda? In simple terms, lambda is nothing but a function. A lambda in simple terms, a lambda, a lambda in simple terms is a function. That's it. It is a function or a method. It is a function or a method. Okay, in simple terms, it's a method which we are replacing in terms of a functional interface. Okay, in terms of a functional interface. So replace lambda expressions wherever functional interfaces are used. This is the basic logic behind Java 8. Are we clear so far? Any doubts in this?
I'm good. Yeah.
Yeah, I'm good.
Okay. Next, we will see some examples. Let's see some other theory part which is useful for us. Okay. So in real-time applications, where exactly lambdas are used? We worked with collections, isn't it? We work with collections. So in collection library, Java people have made replacement with lambda expressions. Earlier to Java 8, collection libraries were different. That is collections framework, what we have seen, array list, linked list, hash set, tree set, etc. All those libraries were written without lambda expressions. But from Java 8 onwards, the entire libraries were replaced with lambda expressions. How they replaced, we will see. Okay. And the other part is GUI. This is also important. Graphical user interface. In Java, when you talk about GUI, we talk about Swing applications, Swing and AWT. Okay, Swing and AWT. Swing and AWT are GUI of Java applications. Swing and AWT are GUI of Java applications. So, lot of Swing code, Swing predefined libraries and AWT predefined libraries were replaced with Java 8 code. Java 8 code and aggregate functions. Lambdas are used to represent. Now we have seen in the previous session JDBC, we use a lot of queries, SQL queries. So from Java 8 onwards, we can reduce usage of SQL calls. We can reduce writing SQL queries. Okay, how we can reduce? By introduction of stream libraries. We have Java people have introduced Java 8 streams, which provide lots of functions, lots of methods. So those methods we can directly work like Java programs only. We need not remember SQL queries, syntax, etc. etc. So that is a little bit benefit. It has both cons and pros. Okay. So certain extent we can use aggregate functions, that is instead of writing or hugely depending on database queries. And next, functional interfaces. The whole concept of Java 8 is revolving around functional interfaces. They are implemented with Lambda expressions. Now, what is a functional interface? We will see. So basically, Lambda use cases are, the target of Lambdas is collection libraries, GUIs, aggregate functions, that is databases, because the real time of the all the real time applications will depend on these four libraries a lot: collection libraries, GUI, aggregate, that is database operations, and functional interfaces, code reduction. So these four major areas were rectified, means whatever loopholes that were there in Java prior to Java 8, those were covered from Java 8 onwards by introduction of lambdas, functional interfaces, streams, and aggregate functions, GU. Okay, and GUI is a major benefit of all these things. Right, now what is a lambda syntax? We have been saying lambda expression. Now what is a lambda syntax? You will have an argument list and connection token body. Same like method only, right? This is method parameters and this is method body. It is as simple as that. Just you will have a connection, just you will have a connection arrow. That's it. A connection token is required, which is an arrow symbol. So a lambda is nothing but a function or a method where you, if you need parameters, you will pass. Otherwise, you don't pass. Just like method only. So these are not mandatory. It is not mandatory. It is optional. Lambda parameters are optional. It is not mandatory. Just like method parameters. Lambda syntax. Okay, lambda is argument list and body. So let us say save this. These are arguments are optional. This is body of lambda expression. And this is the connecting token. This is an argument list, that is lambda arguments or parameters. Lambda arguments or parameters. This is a connecting token. Connecting token. This is a lambda body. Okay, so it is simple terms. Lambda syntax is if you pass any parameters, that will become a parameters or lambda arguments, and this is a connecting token. This is the body of the lambda expressions. Okay, so here this is a functional interface. Now what is a functional interface? An interface which has only one abstract method. We have discussed what are functional interfaces. So a functional interface is an interface with only exactly one abstract method. Only one abstract method. An interface with exactly one abstract method. An interface with exactly one abstract method. So a functional interface is an interface with exactly one abstract method. Okay, now example, if you see, this is print employee details. By default, interface will have abstract methods only. And this return type of this method is print employee details is a method name. It is taking one parameter employee and it is returning employee. Okay, so here is an example. Let's take this example. just take this interface, Control C. Or else you can try here. Okay, let's see this one. Here you have a functional interface calculator. Okay, so same like in this you have print interface, you have calculator. Int calculate integer x comma y. So this is our interface. It is a functional interface, and all the functional interface you can annotate with @functional interface. It's a good practice. Functional interface is an annotation. Now what is an annotation? Annotations are also nothing but predefined methods. Annotations are also 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 predefined methods. Okay, so here @functional interface is used in order to represent lambda expressions. Functional interface calculator into calculate x comma y. So here, if you see, this is your main Java class, arithmetic test, public static void main. Okay. So see here, calculate 1. We are calling calculate 1. I think we are using a different interface, not this one. This is calculate. So this is the method. Calculate 1.
Calculator.
Sorry.
Yeah. It's calculator and calculate. Yeah.
Okay. So this is calculate 1 and this is calculator. Interface calculator. So if you see what is the parameter that we are passing here, calculator means this interface we are passing. This interface we are passing. Okay. So here this method takes interface as a parameter. Okay. Now what we are doing inside this system.in, that is we are reading values. Okay. We are reading values. Now you might say, you might ask me, execution is always sequence, isn't it? So here if you observe, after this statement execution at line number 4, the control will come to line number 8. Means JVM will look for calculate 1 x comma y x plus y. Means it's a lambda expression. So here the execution is simply assignment. It understands the usage of lambda expressions here. It is just like variable declaration. It is just like variable declaration. Okay. So here calculate 1 x comma y x plus y. So this is, we are using addition, multiplication, division and modulo operator. Okay. So here since it is a static method, directly we are calling here. Calculate 1 is a static method. So we are calling directly here. Okay. So at this point of time, calculate 1 x comma y equal to x plus 5, right? So private static void calculate 1. Now this calculator, static method which takes functional interface as parameter. Next, so here in this method calculate 1, we are reading values. We have to read the values. After reading the values, int result equal to calculator dot calculate. Now here lambda expression gets executed. Calculator 1 dot calculate comma x comma 5. Okay. So here at this point of time calculator dot calculate. So when you call calculate 1, it is coming here. It is reading the data. It is reading the data and then it is, you are saying calculator dot calculate. Calculator dot, from where you got this calculator? This one. Calculator dot calculate. This is replaced by this functional interface. Lambda expression calculate 1 is nothing but this functional interface. So that is the reason when we say calculator dot calculate, it is taking x comma y. Now here lambda expression gets evaluated. Okay, this is simply assignment, and here system.out.println result. Now let us see the execution part. Any doubts?
Now, what is the use of the calculator, capital C?
It's an interface.
Okay.
Predefined, it is not predefined interface, it is a user defined interface. If we don't mention this, let's say we do not have this. Okay, that is what your doubt, right? Now we do
Yeah,
not
yeah.
have this. When there is no functional interface, how it will identify this? What it has to understand this?
Okay. No, I was telling like calculator will have two interface like x and y, like that you are telling two variables.
Two variables. Calculator is having, okay, here
Okay.
your variables were here.
Yeah, that x and y. Yeah.
Okay, so here why I am passing two variables, because inside calculator we have calculate method, right?
Okay.
That is why we
It
are
will
passing two parameters. If it has three parameters, then I will pass three parameters.
Okay. Okay. Got it.
See here in this method I have calculator into calculate into x comma y. Now let me say I modified this. See, it is not detecting the functional interface.
Okay. Yeah.
Okay, because interface calculator is a functional interface. In this functional interface, I must have a abstract method.
Okay.
I must have a abstract method which is representing this one lambda expression.
Okay.
Okay, so here that is what whenever JVM starts execution, okay, during the compile time. Now it is, we haven't compiled, isn't it? It is showing us exception. Calculate one. Now let's say what it says. The method calculate one inside calculator in the arithmetic type test is not applicable for the arguments this one. Okay, so
Okay.
it's clearly saying whatever method we have given is not, the moment it sees this syntax, it will search for, JVM will search for functional interface in this class. It has
Okay.
encountered this functional interface. Okay, the moment it sees lambda expression, it will look for the functional interface. So it comes here, it has checked calculator. Okay, inside this you have, when we are calling directly calculate one. Okay, when we are calling directly calculate one here, it means it's a static method. It means it is a
Okay.
static method. Okay, so static method, it will come to calculate one here. Now it has seen interface, functional interface, calculator. So it will come here. It will come here. So, but here there is no matching of this expression.
Okay.
You are giving, this
Okay.
is a synonym for, let's say you are, okay, let's say you are Indian. Okay, you have a nickname also, isn't it?
Yeah.
You have a nickname, let's say Raju, right? So when it sees here it's a Raju, so it knows Raju refers to Indian. Okay, so Raju refers to Indian means it has to look for the Indian definition. It has come here, but definition
Okay.
is not matching here. It says x comma y, but here it is only one x is there, one parameter is there. We are
Okay.
clearly specifying calculate one is having a lambda expression which takes two parameters. Means a functional interface method should take two parameters. That is a blind rule.
Okay.
If you see a lambda expression with two parameters, which means a functional interface method also should take two parameters. Why functional interface? Because lambda expressions are always replacements of functional interfaces. Calculate one,
Okay.
it will come here, calculate one line from line number 8, it will come to line number 15. Okay, so inside the 15 we are saying calculator interface. Now here it comes here, it will see it is not matching, it will give the exception. Dot calculate,
Okay.
sorry, here. Okay, from here it starts working this way, till here it will take no issues. But here when it says two parameters, then the original problem comes.
Okay.
Here it has two parameters, here it has one parameter, integer y.
Okay.
Okay,
That's the calculator method is located.
come again.
Oh, within interface there is a calculate method, right?
Yes, it's a method. This method only we are calling.
Where?
See here, calculate,
Okay.
calculator dot calculate. Now what is this
Okay.
calculate? What is this calculator? This one.
Interface.
Yeah, it's an interface. Okay, or to avoid confusion, calculator underscore obj. Let's give calculator obj. Okay, so this calculator is object reference to calculator interface. So that interface dot object reference dot calculate I have to call.
Okay.
Okay, so here we are using a user defined static method to call a function. That's it. To call a lambda expression, or to execute a lambda expression. Let's proceed. Enter first value. Okay, let's say 45. Enter second value 10. See 55. Addition. First it is performing addition. Yes or no?
Okay.
Now again it is saying enter first value. Means where is the control here? Means what? It has executed. Once it's encountered this, immediately the control will come here. Calculate 1. It is reading the data and then it is
Okay.
evaluating the expression. Okay. Next it is saying enter first value. Okay. Means
Okay.
what? It has executed this one. Calculate 1. Multiplication. So let us see 25 first value into 400. Okay, so it is printing this one, right? Again where control is going to line number 10. From line number 10, the moment it sees calculate 1, control will come to public private static void calculate 1. So here it has a this calculator object reference. Okay, so it is reading the values, enter first value and second value, and then it is saying calculator object dot calculate x comma y. Lambda expression is here executed with this replacement. When you pass x comma y, calculate x comma y. Now here execution takes place at line number 22. At line number 22, this lambda expression is executed and stored inside the result.
Okay.
Okay, so here lambda expressions are nothing but they are replacements for a functional interface methods. Lambda expression definition should match with the functional interface method. Lambda expression definition should match with the functional interface definition. Is this point clear?
Okay. Yeah.
So in other words, this usually when we use interfaces, definition we provide inside the class. Yes or no?
Yeah. I've seen that. Yeah.
Whenever we use an interface, what is a way that we use? We use this way. Let's say class ABC implements calculator. class ABC implements calculator means now we have to provide a definition for this in older style. Yes or no? Class
Yeah.
ABC implements any interface means it has to provide a definition for this. Now all this stuff is not required here now in lambda expressions. We simply create a lambda expression for this interface based on this interface, and how to call this method. Again, it's a fundamental rule. What is a object oriented fundamental rule says in order to access any method you require an object reference. So that is why you are using object reference dot calculate.
Okay.
It is just like calculate is a method which you are defining inside the calculate one. The definition for calculate is provided inside calculate one
Okay.
instead
No,
of.
I got it. Yeah, I got it.
You got it right. The
Yeah.
method definition, if you have any interface, functional interface, now for that method definition where you